Well, this is a story. This is a story about taking tech decisions, which drives in positive or negative way your growth as a company, your growth in terms of customers, in terms of data, and in terms of product success. Um, First, let me introduce myself. My name is Filip Yankov. I'm from Bulgaria. Currently, I'm a chief architect at Novartu, a Bulgarian consulting company with 15 years experience, predominantly in e-commerce. And today I'll share with you some stories and some data about it. But for me, I have like a third of my experience, 7 years, is into corporations, SAP, Microsoft, VMware, where I've been developing the cloud solutions of those. And some notable startups, Joblabs, Top Tower, and Tablera. Few of those are very big and have ton of data. And I collected really lots of experience. I'm lucky with it. And I've been doing games, I've been doing retail and commerce, I've been doing insurances, and the Top Tower is a freelance network, and I've been able to contribute with lots of different technologies. And today I'm gonna share with you some stories. Um, let's dive deeper. Like I said, the stories will be in the commerce field, specifically the retail, which means the cases we have supermarkets and we want to have them as our customers in a retail management platform, and we want to measure categories, performances, buying patterns of customers, assortment planning, and lots of different, I'll call those features and charts. And we want our platform to have many of those to be able to contribute to the success of the supermarket brands throughout the world. But what I'm going to share with you today is basically from my experience. I have been into the last years of development of such platforms, like the 10th plus year into development of such platforms, and I gathered data, history data, how those developed and where are the potential moments in which you could take different decisions so you drive better growth. Um, but just more about the platform. We'll have such charts like here. The idea is to have such, and the idea is to develop such platform. We'll start from scratch, and the data I've been sharing is like an average or a collection of my experience and what I'm hearing from people in the field. And the decisions I'm seeing from my experience and from people in the field are kind of similar, but are not leading to the best outcomes. So let's start first with describing few techniques that are probably inside or are missing in some of the history of those. The first thing is partitioning. Basically, we'll have some data in some database, obviously, and this data will gonna be really big. Like we want not even terabytes, we want petabytes. So definitely we want partitioning. What that means is we want the data that is here inside that single database to be partitioned in a way that data, for example, from supermarket 1 and data from supermarket 2 to be in separate tables, which means in a single infrastructure to separate the data in favor of the queries going towards first or second data to be faster and cheaper. Second technique is sharding. What that means is let's separate that data physically. So let's have a separate database instance, separate infrastructure, and move that data inside here, which again can lead to better performance in some ways. Third technique is caching, which obviously will have some server we developed in some language that is going towards that databases. And what caching means is let's have some other server that 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 helps the server and cache here the query. So you go here for data, data is coming back here, and you have to render it to a client browser. But instead of going every time to the database, instead of querying every single query multiple times per day, you'd better first store it in the cache and then go towards the cache, which is a solution that will lead to way faster time to load the data inside the browser. And last technique, the thing is where from the browser, the client browser, and the server, wherever it is in your infrastructure, how and where that data is rendered inside the page here. So if you have that page, here we have data and that data is coming somewhere from the server. The thing is, in this screen, is the data rendered inside the browser, which means computation inside the browser, or is that page rendered inside here as an HTML, and the HTML is sent to the server, which is server-side rendering or client-side rendering or server static site generation or infrastructure-side rendering. Those are four techniques that are again kind of caching, which maybe cache the HTML and returns the same HTML every time, or just send small pieces of data and client side rendered, which means render the data at the browser. And I will have to use those techniques to the development and see where I'll now do some math to help you visualize how the decisions could be taken without knowledge or with knowledge and leading to success. And at most, and what my request for all of you is just measure the performance a priori, which means do that math like what I'll be showing you now, before you start development, before you spend your money, and before probably crash company at the XY year of its development, just because you took decisions that made you collapse. Now, I'm going to be sharing with you just a technology stack, which probably at the server you'll have Java, or you'll have Go, or you'll have Node.js, or you'll have PHP. And at the front end, you'll have either vanilla JavaScript or Angular or some other framework similar to Angular, like React or Vue or whatever. But those probably matter at some points of time, and you'll see them. And of course, you'll have Postgre or MySQL or AlloyDB or some other database solution. You'll have virtual machines at some cloud providers, or you'll have virtual infrastructure at some place like DigitalOcean or whatever similar. But the key thing here, and what I've started with, we'll know that this retail case, if that retail management platform as a, let's say, uh, software as a service solution scales really well, definitely it will have not even terabytes, petabytes of data. And if we want to be prepared, we'll have to start with that in mind and develop some solution at first. Not think let's just develop something front end, back end, whatever. Let's just have some customers, and at some point of time, our cost will be way much than your revenue. And if we'll start with a bigger case, you know that in retail you have categories, you'll have products, you'll have ton of data, you have post-terminal data, you'll have retail partners, you'll have inventories, you'll have prices, etc., etc. There is really a ton of data, and uh, the thing I'm not highlighting here is that we'll probably be needing, and we'll know that from the start, we'll need a data warehouse solution that is auto scalable and that is able to handle petabytes of data. And those that are similar and automatically scalable are Snowflake or BigQuery. It doesn't matter which one you'll choose, but you'll definitely need one. But how from my experience start the three examples I have in my experience, and a 10 tenths more that I heard from colleagues in the field. Those examples start with, let's say we're a startup, let's say we're business guys, and let's say we'll be developing that platform. We don't have a technical co-founder, and we'll go hire some consultancy or some outsourcing company that will develop, let's say, our first version of that platform with, let's say, 10 charts. Okay, fine. What will they be developing? At most probable way is a PHP backend with vanilla Java server with a Postgres database, and it's hosted in some VPS somewhere, DigitalOcean, Scaleway, or whatever other similar. And the cost will be like for the development of that platform, some bucks of money, which probably are cheaper and probably are a way to start. But let's see how this will go. Since here into that picture there is no scalable and automatically scalable database or warehouse, how this is called, and see how this thing go. I'll describe here in those tables what's happening with key observations we'll have to measure, and like I said, be able to be doing it beforehand, before even going to the outsourcing company and say, hey, we need you to develop a platform with 10 charts, some user accounting, etc. Well, obviously, the features of our platform will be charts. Obviously, the feature richness of our platform will be how many products there are inside. With products, I mean tomatoes, bananas, cucumber, and chocolate, milk, whatever is inside a supermarket. And when we scale and we enroll lots of more customers, clients, we'll be having more and more products. Obviously the amount of data is very important. Or the next important thing is the load time, which is the load time of those charts here. I mean this, like when you load that screen, how much time it takes to load it, seconds, minutes, hours. Just because the clients you'll use those charts, and that's definitely an advantage if loading time is slow, like a matter of seconds. Next thing is how much is the cost of that infrastructure and how much is our revenue. And let me now first describe that first case. And right here, I'm not, I'll be writing since I want to explain how the numbers are evolving. In the first 2 years, we'll start with the PHP solution first, like PHP from some company, the one on the picture that I've shown. And in the first 2 years, we'll be able to develop with a small tech team 10 charts for the first 2 years. We'll be able to enroll clients that will be giving like 400 gigabytes, and I'll be writing it in terabytes, since below will be only terabytes, and we'll have 40,000 products. 40,000 products is like a normal supermarket chain that is spanning the full country, let's say. And having 400 gigabytes of data, this is terabytes here, 400 gigabytes, and the queries that are normal towards to load into those charts, probably those will take 5 seconds. 5 seconds, not so bad, let's say. The cost will be, I'll call it X, and I'll name it 1 or 2x, and below will be just multiplying, so you see how this evolves. And the revenue I'll call it y, and again we'll multiply below. The the next is what? First, we're starting with some revenue, we're starting with some cost. Basically, we are happy, and what the CEO is saying, come on, we'll have to enroll more products and more clients, and we'll have more charts. So we'll be developing the third and fourth year charts, and we'll be enrolling much more clients, 1.7 terabytes of data. And just because of that, load time will be 6 seconds, and the cost will be basically twice. And the revenue, since we've been enrolling like 3 or 4 times more customers, it will be 3 times like the previous period. Continuing the next periods, our CU is more aggressive, and not our, but in most of the cases, like 4 years are already spent, and we've been not scaling enough. So our CEO is, and most of the CEOs will say, "Hey, we'll be aggressive." What that means, we'll be aggressive with 5 terabytes, next with 15, which is plus. Which what I mean plus? What I mean is that those terabytes are in addition to that a priori. We'll be having 40 and we'll be having 70 terabytes. And here again we'll be aggressive, and will be which means the customers will be assigning. The supermarket chains are having tons. Well, okay, let's not be. I'm missing here a thing. Let's be not so aggressive, adding 100K products, and that total at the end will be like in a matter of 500,000 or more. But what will be happening with the load time if we continue? If we continue to the 8 year with the same solution and just developing and redesigning that backend code in PHP language to handle all those products and to handle all those data and to optimize the queries, what's going to be happening is that the queries will take lots more time, and this will be in seconds. um well, again, a mistake. It should be way much, since 5 terabytes is 3 times more, so it will be 20 to 30 seconds. It will be 20 here, but with 3 times more, we'll have like hundreds or 200 seconds, and this is like 4 minutes, which is slow. And here what we'll decide is to introduce that warehouse that I'm telling you, which no matter if BigQuery or Snowflake, one of those. And when introducing it, it will lower the time of the first queries, but the since we're adding much data, will be like in a matter of what, almost 5 to 10 minutes for the slowest queries, which is much. And here at such amount of data, we'll be having like more than 10 minutes, like 12 minutes. And the cost progression will go really low, like a lot. And we'll be seeing how here, when adding BigQuery, even the cost have to be lowered somehow. but but uh, but not so low. Like this will gonna be huge, like 60, since this is automatically scaling. So when we're in automatic scaling and we give a query to the data, what will happen? What will happen is that it will automatically scale the infrastructure, which is cost, so you're able to handle the as fast as possible the query. And there is a different option in BigQuery to prepay slots, which means paying the infrastructure and fixing it, and not being able to automatically scale, which will like fix the load time, but will fix also the price. And the price is like fixed. And the revenue, since it all depends basically on that data, will go like 3 times much every time, like 2 to 3 times every time. And at the end, we'll have 75 times more revenue at the end, but no more charts. And the thing and the bet is that 8 years will be with the first initial solution and refactoring, which is kind of a thing that we have to think about. And in a matter of time, I'll be just showing you second example. And since all the examples are same and it's gonna be taking time, probably I'll just write the last, which is using all those words like partitioning, sharing, caching, sharding, whatever else. And you'll see just one example, but you could experiment with it. Like at first, okay, we'll start with 10 charts, those 2 periods, but we'll be very, very aggressive. We want to be very aggressive. We want to have twice as much products at first year, and we want 5 times more at the second period. We want to start with a terabyte, and we want six more. And we at first those is 2 3 seconds load, but how that is even possible, BigQuery have to be added here. Like those warehouse have to be in the initial solution, which means if I go back here just in the architecture, those like relational databases like Postgre have to not be used. We have to use Snowflake or BigQuery at first, which uh, just is getting initial cost, like the development of the initial cost will be like 5 to 10 times more expensive. Will take probably not 4 months for development, but a year. But we'll be able to scale really, really well. And what that means, the cost in the initial cost is way more since it will handle most of the data at once, and the revenue, let's say, will be twice. And what's going to be happening? Obviously, after the first period, we want to prepay that BigQuery again to not be able to automatically scale, and we want to invent the cache. Like we want every query towards the database to be cached, to not go every time, since every query costs money, and going towards the cache costs no money, costs the money just for running the cache, which is really cheap. And what that means is we'll have a matter of 3 seconds. Every return of the query that is in the cache will be not much than 3 seconds. And like 90% of the queries will be 1 to 3 seconds. And the rest will take, let's say, 150. And not let's say, those are real numbers. Like I'm saying, average from my experience. And since we've grown a lot, our cost will be more, and our revenue will be way more, like 5 times more, depending on the customers. And again, having this solution is giving us options to scale. Our CEO is aggressive and assigns assigns contracts with more customers and with more, which are giving more data, and we want here this to be the same. What we have to do for this to be the same is we have to think carefully. Okay, we have a server, we have a browser, we have a database, we have a cache, and we have a warehouse. And how the logic goes, the browser goes towards the server checks first if there is a result in the cache. There is not. Okay, then goes towards the warehouse, which is the most expensive from that infrastructure here. That handles the query, returns it back, the server stores it into the cache, and then returns it to the browser. And here in the database, we'll have just user management, like users from our customers, those different brands that we're signing as customers, which basically we could not even look at this thing here. And basically, we have a ton of data here, and we have petabytes. We will be having petabytes here at the warehouse. But like I mentioned, we'll need caching, we'll need partitioning, we'll need sharding. What sharding means, you will have separate warehouse. What partitioning means is, let's not store data whatever inside here. Just draw lines and store carefully. Let's say Nestle data is here, Carrefour data is here, little data is here, just just because if when you have queries that is going against the warehouse, we want to not be able not allowing the queries to span the full warehouse, but just a portion of it will be, which will make the queries cheaper. And in addition to, since this picture is just to here, the first period, the second period, so we are here. And what we want to develop here in the second period, so we'll be able to use here and to be able to scale way more, uh, is basically pre-compute queries, which means lots of our users which will be using those charts are data scientists, and data scientists that are hired for working for the supermarkets will be using the charts to get dynamic pricing and optimize the supermarket spend money. And they'll be doing they'll be opening charts, let's say one per minute, and we'll open hundreds of those charts, looking at the data, the prices, the inventory, hundreds of times per day. But the behavior of every customer, a data scientist, is like usual, and we could store all the queries in some cache, the queries, just not the results, the queries. And those queries, which is like history of queries, we could see this day these queries, the second day these queries, and we could see that very similar patterns of what queries are needed and what data are needed by those data scientists. And when we have that patterns, we could preload those data before even clients want them, which means uh, will be not be reactive. Our server, since this system up to here is just reactive. We have client in the browser, clients wants something, the server returns it. What I'm saying here is our server becomes active, knows that behavior history patterns, and in the meantime, even without browsers or clients wanting data, he'll be going towards the warehouse and storing the results into the cache. And the next day, when the browser pops up and the clients want something, the data will be in the cache, which means here we'll be able to achieve way more. We'll be able to preserve that, and we'll be able to scale like more aggressively, like 3 to 5 times more every time, or at least 50%, which again, those numbers are terabytes. And if I have to finish, let me share with you the cost. The cost obviously progresses, like not multiplied 5 times every time, but in sometimes that will be developing that recomputation and optimizations, uh, will be having like not 5 times more, but just 2 times. And obviously, this, if we compare it, is way much, like it's 10 times much the cost. But now let me share with you what will happen with the revenue. The revenue, again, here 5 times more customers, 5 times more customers, and with the pre-computation. And by the way, here we'll be able to add features if we change the server technology, not to PHP, but some other language like Java or like Golang, which be able to scale and to do those pre-computations and save some time for developers to develop new charts, which means new abilities into our platform, which will scale the revenue. And the revenue is not gonna be scaling just because we are adding more data and more clients. It will be scaling just because our platform will be more feature rich. And here we'll have 300 times more, he'll be having 400, and he'll be having 6 to 800 times more revenue. And again, if we compare those two numbers here, uh, we are leading to something really better, and we are leading towards growth for our business, growth for products, growth for clients, and growth for feature richness of our platform. And if that is really simple math and is for like 20 or 30 minutes described, what I'm sharing with you is just be careful, just be careful, just because in the retail management, the first scenario, we've missed to optimize the driver's route. We've missed to have efficient data storage for drivers, which are our suppliers that are taking customers' orders or adding inventory inside the supermarket. This is some missed product. Optimization of in-store staff movement. What that means is if that's the building, and here are where you'll just going in some way into some path to buy something. The path, the place where you'll buy things is into that part of the building. In that part of the building is the store, and into the store there are staff of a supermarket that takes products from here, and when here it's no more left from bananas or from tomatoes, those stuff are moving around the store and into the customer zone, let's say, and that part could be optimized. Obviously, in some bigger supermarket chains, we have price predictions and dynamic pricing, which is something that very few are able to do nowadays, and very few nowadays are being able to operate with machine learning. What happened in the normal case here, which I mean this one, which just start with PHP and end with the PHP. At the 10th or 11th year, the CEO decided, let's hire an intern mathematic guy who does statistics and is third grade at university, and better be cheap and better try some things with machine learning. Let's copy like 10 terabytes of data without thinking how this will cost, just for storing that data and doing queries from the machine learning towards it. And this is like a cheap solution that's not ending well. And basically, I'll stop here and just summarize. Be cautious with your solutions. Before even starting, just do some math, uh, get some consultancy if you need. It's prices. Like it's better start well and scale well, and not be like ruining your business in the fifth or 10th year just because of some missed decision that you had to take.